Hi, in this video, we are discussing the ninth numerical from the exercise for the chapter Laws of Motion, which is also the fourth chapter for 11th standard physics. Now, this is a pretty straightforward question. In this question, we have been said that our force is a function of displacement. To be specific, it decreases linearly with displacement. मतलब जब हमारा force so for a displacement of 3 meters, our force is 5 Newton, and when the displacement increases to 5 meters, our force reduces to 3 Newton. And then that becomes our given sets of data as well. So our F1 is 5 Newton for a displacement of 3 meters, F2 is 3 for a displacement of 5 meters. As I said, linearly decreasing. Based on this, we need to calculate the work done by this force during this displacement. During the displacement from 3 to 5 meters के बीच में work done calculate करना है. How do we do that? Well, we know that by definition, work done is the integral of force dx, provided this format works only if f is a function of x. And for this question, it is. And one way to calculate is to calculate the area under the f by x graph. And that's what we are going to do in this particular question as well. So let's start with the solution. So if as per the solution, if we plot a graph between our f and x, basically a graph that represents the relation between force and displacement, we know that it will be a straight line. And this line will pass through 2 points. Our first coordinate would be the f1 x1, and our second coordinate will be the f2 x2, which is given to us. So let us quickly plot the graph. So on the graph, we are representing force in newtons on the vertical axis, and then we are representing x in meters, that is displacement in meters along the horizontal axis. As I said, the graph of the relation between force and displacement has to be a straight line with a decreasing curve, and this is a straight line. And on this straight line, we plot our two special points, that is the initial point where we have force F1 for initial displacement x1, and then we have our force F2 for a final displacement x2. The values of the force is on the y-axis, the values of the displacement is on the horizontal axis. So a way to calculate, and what we have to do is we have to calculate work done for this particular interval. That is when we go from this initial to final displacement. For this interval, we have to calculate work done. And we know from the formula that if we calculate area under this particular line, we would get our work done. So basically area of quadrilateral B dash, A dash gives our work done. So as I said, work done is equal to the integral of f dx from the limits x2 and x1, where this is the initial and this is the final displacement as per the definition. And in terms of graph, it is the area of our quadrilateral B dash, A dash. Now we can calculate the area directly, but from the graph, we can say that this particular area is made up of two simple shapes. One is this triangle CAB, and the other is a rectangle CB B dash A dash. So, and as you can see, I have color coordinated the areas to reflect the areas from the graph. So we have to calculate the area of triangle and an area of rectangle. We know the formulas. Area of triangle is half into base into height. So the base is BC over here and the height is CA. And then the area of rectangle is simply length into breadth. So we have length as BC and breadth as BB dash, or any combination for that matter. If we were to calculate the lengths of this particular segments, so BC becomes 5 minus 3, that is 2 units, and AC becomes 5 minus 3, 2 units as well. So if we were to write the equations, we will have BC as 2, AC as 2 units. For the rectangle, we have BC, which we have already found as 2 units, and then we have BB dash, which is 3 minus 0 as 3 units. So the values for all the segments has been calculated. If we were to solve this, we would get our work as 8 joules. So this is the work done by the force during the displacement from x is equal to 3 to 5. So this was the sum. If you want the PDF of this solution, make sure you check out the description box. With this, I hope this helped you. Thank you.